MicroPython is a special version of the Python programming language that has been simplified and optimized to run directly on microcontrollers. These are tiny computers inside boards like the ESP32, ESP8266, and Raspberry Pi Pico. What makes MicroPython powerful is that it takes the familiar and easy-to-read style of Python and brings it into the world of electronics. With just a few lines of code, you can make LEDs blink, read sensor data, or even connect to the internet, all from a small chip. One of the main strengths of MicroPython is its beginner-friendly approach. Since it uses Python syntax, students and hobbyists who already know basic Python can quickly adapt to controlling hardware. Instead of writing long lines of C or C++ code like in Arduino, MicroPython lets you turn an LED on with a simple command like led.value 1. This makes it ideal for rapid prototyping and for those who want to see results fast without getting stuck in complex programming details. Another great feature of MicroPython is the interactive REPEL, or read-eval-print loop. When you connect your board to a computer, you can open a terminal and type commands line by line to test your ideas instantly. This means you don't always need to write and upload full programs before experimenting. You can toggle pins, check sensor values, or debug your circuit interactively, which is a huge advantage for both learning and development. MicroPython is also efficient and lightweight, designed to run on boards with very little memory. Despite its size, it supports essential hardware functions like GPIO control, I2C, SPI, and UART communication, as well as PWM for dimming LEDs or controlling motors. It bridges the gap between software and hardware, allowing programmers to step into electronics and makers to dive into coding with ease. To give a quick example, blinking an LED with MicroPython only takes a handful of lines. You simply define the pin connected to the LED, set it as an output, and then use a loop to switch it on and off with delays. In just 5 or 6 lines, you have a working hardware project, something that normally takes much longer in traditional embedded programming.